Many recording devices or analysis methods return an array of values of various dimensions depending on the application. Sound recording, for example, measures the oscillations of a membrane in a microphone, and it's sampled at a given frequency so that if we begin to plot that over time, what we see is a waveform, which is what we would expect. In images, though, we're talking about two-dimensional array, a two-dimensional matrix where each pixel is located at a particular row and column. And at each row and column, the information that is stored is information about the color value of that pixel. And we'll talk more about what those are. And typically, what we see is a red, green, and blue value, which makes up the color value of that particular spot in the image. So the way cameras begin to work is that the bottom layer of the sensor is made up of a whole bunch of photodiodes. And those photodiodes begin to measure the intensity of light that's hitting that surface. But what we want to do is begin to filter the light out so that we're only measuring one frequency of light, whether that's red, green, or blue. And then what we do is composite those together so that the resulting pattern of red, green, and blue channels give us an image that represents what we consider or perceive as a real-world image. But we don't have to just measure visible light. There are cameras out there that begin to measure other spectrums, including infrared light, which begin to reveal patterns of heat losses in buildings, among other things. We can also use infrared light to begin to give us information about the three-dimensional environment. So what you're seeing here is time of flight. We send a beam of infrared light out from the camera and wait and measure the amount of time it takes to bounce off of an object and back to the receiver. And so based on that time, we can begin to measure the space and begin to make a three-dimensional volume out of that space. So we talked about two-dimensional images and how they can be represented in a matrix of values. We can extend that to a third dimension, and what we would refer to that is, instead of a pixel, a three-dimensional pixel is usually called a voxel. Its nomenclature is pretty much the same, but now we have a third dimension in which we have to locate the pixel, or the voxel. And there are lots of different ways voxels can begin to be used. In the healthcare industry, for example, what we can see is magnetic resonance imaging is three-dimensional reconstructions. So it takes slices of MRI data and stacks them together and then uses intelligent algorithms to begin to make three-dimensional reconstructions of that. And we don't have to just stop at three-dimensional. We can actually go to higher order dimensions. Functional magnetic resonance imaging, for example, measures the amount of blood flow through the brain over time. So we're adding another dimension. So we can begin to see patterns as people begin to change their thought patterns by looking at things or thinking about things in different ways. We can begin to see patterns in the blood flow throughout the brain, which begin to reveal other types of information. There's other applications like structural optimization. One thing that we can think about is topology optimization, which is a structural analysis methods where we actually create a volume of material that's started out with a series of voxels of generic information. The red volume over on the left hand side of the screen is actually a region of a support area, and the blue is a region that's indicating a load. And what happens in the optimization routine is that it begins to run through a finite element solver. It begins to analyze where the stress distributions happen through that three-dimensional volume. And then based on those stress distributions, it begins to change the opacity or the color of that particular voxel. So what we see is actually putting material where it's needed or removing material where it's not. So as an optimization routine, it's a very interesting and unique way to think about designing objects or making objects that are actually very efficient for what they're actually trying to do.